Hi class, this video is going to be over section 5.3, which is trigonometric functions of any angle, right? So objective 1, we want to be able to evaluate trigonometric functions of any angle, right? So let me write up some information here. So let's have triangle POQ be a right triangle with acute angle theta. Right? So essentially we have, some right triangle here. Where here's theta, here's my right angle, here, here's my adjacent side, here's my opposite side, here's my hypotenuse, right? Let's let this be P0 or O Q, POQ, right? Well, and let's actually see if I can move this down some. This figure. So it's not running into what I had just written. Oops. Alright, so here's the opposite. Whoops. Jeez. Had my eraser still on. Here's my opposite. I let this be P and this be Q. Alright. So then what I want to do is take this and place triangle POQ in standard position. And let P equal the point x comma y. Right? So then the scenario we would have now, right, so remember in standard position, we would put this triangle like this, right, where this keeps going, right, we're thinking of that being like a ray. Where here's theta, here's O, this point here would be P, which is x comma y, point P, here's Q. So if this is the point x comma y, right, here's my x-axis, here's my y-axis, then this distance here, right, would be x units, right, so this would be x, and then this distance, let me grab another color, this distance here for this side, right, the opposite side, that would be y units, right, and that's just pulling it apart from the ordered pair, right? So then what we can also do is let's let the hypotenuse side, let's let that be a distance of r, right? So then, now that we have this new image, what our goal is and what we're trying to do is let's define our 6 trigonometric functions based on x, y, and r, right? And we'll see that will be useful. So for example, sine theta is equal to, the opposite over the hypotenuse, which in this case would be y over r. Right? Cosine of theta would be equal to the adjacent over the hypotenuse, which is equal to x over r. tangent of theta would be equal to the opposite over the adjacent, which would be equal to y over x. Right? Cosecant of theta would be equal to the hypotenuse over the opposite, which would be r over y. Right? Secant of theta would be equal to the hypotenuse over the adjacent, which is equal to r over x. Then lastly, cotangent of theta, which is the adjacent side divided by the opposite, which is equal to x over y. Right, so those are my 6 trigonometric functions defined using x, y, and r, right, from the diagram. So then the next thing that we want to discuss is how the sines are going to work with the 6 trigonometric functions, right? So let theta be any angle in standard position with point P, x comma y, be on the terminal side, and let r equal the square root of x squared plus y squared, where r cannot equal 0. Represent the distance from point P, which is x comma y, to the origin, which is 0, 0. Right? Then the following will be true, right, that we looked at above. That sine theta will equal y over r. So it's just copying it from above. Cosine theta would be equal to x over r. Tangent of theta would equal y over x, where of course x cannot equal 0, right? We already said that r can't equal 0, so I didn't have to write that for sine or cosine. And then cosecant, I got a little bit more room. Cosecant of theta would be equal to r over y, where of course y cannot equal 0. Secant of theta would equal r over x, where x cannot equal 0. And then cotangent of theta would equal x over y, where in this case y cannot equal 0. Right? So remember, we're saying that these can't equal 0 because we can't divide by 0. Right? And if you're wondering, how we got this value for r, that's just using the distance formula, right? So if you forget what that is, right? Remember, if you have 2 points, let's say we have point 1, which is equal to x1 comma y1, and point 2, which is equal to x2 comma y2, right? If I want to find the distance between these 2 points, right? Essentially, you can make like just a generic diagram here, where let's say this is P1. Actually, let this be P1 and this be P2, right? Then if I want to find the distance, we can actually make a right triangle, right? And use Pythagorean Theorem. So we're trying to find this distance D. So the difference between this, this side would be y2 minus y1. The distance here would be x2 minus x1, right? Based on their ordered pairs. So then we could get, d squared equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared, right? The distance formula, and then we could take the square root of both sides, and we don't have to write the plus or minus because distance is positive. So we would just have the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Right, so this guy is known as a distance formula, right? So just using that distance formula, plugging in those 2 points, that's what we get, right? All right, so then let's see. So what I want to write next, I have here like in this space, but it's kind of tight. So I think what I'm going to do is just come off to the side here and write this down. So you could write on your paper, but I want to try to not write it too small for the video so you can see it well. So basically, let me just draw a diagram describing the situation that we have. So we're in the xy plane. We have this angle theta that's in standard position. And we have this point, which is point P, x comma y, so it's a point on the terminal side. Then we have, I'm going to draw a dotted line to show that this is a ray that's continuing. What we also described is that this distance between the origin and point P we're calling r, distance of r units, right? So then if we think about what the sine will be for each of the trig functions in each quadrant, really we only have to pay attention to x and y, right? Because we already said that r cannot equal 0, right? So notice that the trig functions are ratios of x, y, and r, right? That's what this part is saying, right here. So the sign of sine or cosine, for example, depend on what x and y are, right? So, oops. So if I just draw, just an xy plane, right? You should know that, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, right? So all the points in quadrant 1 are going to have a positive x and a positive y value, right? Because we go up, or to the right and upward to get into this quadrant, right? Quadrant 2, whoops, not a very good 2. Quadrant 2, all the points in here are going to be a negative x value and a positive y value, right? Because we're going to the left and upward to get into there. Quadrant 3, we're going to the left and down, so those are both negative directions. So we have a negative x and a negative y. And then quadrant 4, we're going to the right, so that's a positive x, but downward, so that's a negative y. Right, so that tells me the signs of the x and y values for all the points in the 4 quadrants, right? So then, now thinking about the trigonometric functions, right? And I'm just going to focus on sine, cosine, and tangent for right now, right? So if we look at, tangent of theta, that's equal to y over x, and both of these are going to be positive, right? So we get a positive answer, right? If we look at sine of theta is y over r, right? So I know that r is going to be positive, and y is also positive, so this gives me a positive answer, right? And cosine of theta is equal to x over r, which both of these will be positive in the first quadrant. So we get positive divided by positive, which is a positive answer, right? So in other words, all of them are positive in the first quadrant. Tangent, sine, and cosine are all positive, right? So if we think about tangent, sine, and cosine in the second quadrant, so the difference is x is going to be negative, right? Y is going to be positive. So what that tells me is that tangent, oops, let me maybe use a different color. So tangent of theta is going to be equal to y over x, right? Let me keep this consistent. Let me just keep using the pink, right? So tangent of theta is going to be equal to y over x, which in this case is going to be a positive divided by a negative, which gives me a negative answer, right? So tangent is going to be negative here. Cosine of theta is x over r, which this would be a negative divided by a positive, so this gives me a negative answer, right? And then lastly, sine of theta is going to be y over r, which is positive divided by a positive, which gives me a positive answer, right? So the only trig function out of the three that we're focusing in on is sine is positive in the second quadrant, right? And the reason I'm not worried about cotangent, cosecant, and secant right now is because, you know, cotangent is just going to mimic the same sign as tangent, right? Because if I flip the numerator and denominator, the positive negative sign is going to be the same, right? So that's why I'm not concerned about the other three, right? So they will follow. So then sine of theta is y over r. So in the third quadrant, we have y is negative and r would be positive, so this gives me a negative solution, right, for sine. Cosine of theta is x over r. So x is negative, r is positive, so that gives me a negative answer, right? And then tangent of theta is y over x, so that would be negative divided by negative, which is positive, right? So in the third quadrant, tangent is the one that's positive, right? And then lastly, quadrant 4, right? So sine theta is y over r, which y is negative, r is positive, so this gives me a negative, right? Cosine of theta is equal to x over r. So x is positive, r is positive, so we get a positive answer. Then lastly, tangent of theta is y over x, so that would be negative over a positive, which is negative, right? So that's just walking through what those signs would be. And that's not, you know, not something we would typically, you know, write out each time, but we're just kind of exploring, you know, what these signs are and why. So what we have to kind of help us remember the signs is we just remember where things are positive, right? So this saying all students take calculus is a way to help us remember, right? So if I have an xy, you know, plane, then we just write all students take calculus, right, following the order of the quadrants. And then so what this A stands for is, you know, all. That remains. The student stands for sine function. The T in take, that's the tangent. And the C for calculus is for cosine. So what that does is that reminds us where things are positive, right? So this shows where the trig functions are positive, right? So if you want to write this a little neater, you know, we would have all sine, tangent, and cosine, right? And don't forget that, you know, cosecant would follow sine, cotangent would follow tangent, and secant would follow cosine, right? Because they're just reciprocals of one another, right? All right. So the reason why, you know, this is helpful is it turns out that, so we're going to look at what's called a reference angle. So it turns out that we can make essentially a right triangle, you know, for any degree theta, find this reference angle, and we can figure out the trigonometric ratio. But what's going to, you know, possibly be different are the signs, right? And that's going to depend on what quadrant that it's in. So that's why we went over that, and we're going to go over that in a little more detail in Objective 2 when we look at what reference angles are specifically, right? So this is all going to, you know, be coming together here. So what I have next is looking at an example, example 1. So We have a point P that has the coordinates -5, -7, be a point on the terminal side of angle theta drawn in standard position. Find the values of the 6 trigonometric functions of theta. Right? So I like to start just by drawing a picture so I can visualize this. So the point -5, -7 would be somewhere in the third quadrant. Right, so here's theta. Here's my point P, which is -5, -7. Just some things to note. We know that x is -5, the y value is -7, and we don't know what r is yet, right? But we do know that r is equal to the square root of x squared plus y squared, right? So r would be equal to the square root of -5 squared plus -7 squared. So this would give me r equals the square root of 25 plus 49. So this would give me r equals, that'd be what, square root of 74, right? I don't think that doesn't simplify, right? No. So r is equal to radical 74, right? So this is kind of like my key, right? Because remember, we just talked about putting the 6 trigonometric functions in terms of x, y, and r. So if I have those figured out, I can just plug them in, right? So then, if I want to, maybe find sine of theta is going to be y over r. So y is -7, r is radical 74, right? So I need to rationalize the denominator. So we'd multiply by radical 74 over radical 74. So that gives me -7 radical 74 divided by 74. And that doesn't simplify, right? Let's see. And I could, pretty easily go ahead and find cosecant of theta, right? It just follows directly from this. So I would be focusing in on this part, right? Because we just need to flip it. So we have radical 74 divided by -7, right? So we're focusing on that one so we don't have to rationalize the denominator, right? So then next we could go ahead and find cosine of theta. So cosine of theta is x divided by r, which would equal -5 over radical 74. So very similarly, right, we need to rationalize the denominator. So multiply the top and bottom by radical 74, then we get -5 radical 74 divided by 74, and that doesn't simplify, right? So then secant of theta, right, that's 1 divided by cosine of theta. So I'm going to focus in on this guy and just flip it. So that would give me radical 74 over -5, right? So then tangent of theta is equal to y over x. So this would be -7 divided by -5, which is the negatives would cancel, so it would be just 7/5, right? And then cotangent of theta equals x over y, which would be -5 over -7, which simplifies to be just 5/7, right? So not too terribly difficult, right? All right. So the next term that we're defining are quadrantal angles. These are angles with terminal sides on the coordinate axes, right? So they're, the terminal side is over top the x or y axis. So something that we want to recall is that if you divide by 0, the expression becomes undefined, right? We can't divide by 0. So an example is 5 divided by 0 is called undefined, right? So that's important to remember. So if we want to find exact values of sine, cosine, and tangent for the given angles, right, we can, if you'd like, we can draw a picture to help us with this. So if I have just this x, y coordinate plane, if my angle theta is at pi over 2, some point P on this terminal side is going to be here, right, where this is theta equals pi over 2. And my point P, if you think about this, the x-coordinate, since it's on the y-axis, is going to be 0. And remember that this distance here is r, so that's going to match up with my y-coordinate. So my y-coordinate is going to be r. So our point P is going to be 0, r. Right? So some things to note here is that x is 0, y is going to be equal to r, where r is greater than 0, right? Because we know that's true, that r has to be greater than 0. That's something that we assumed. So then if I try to find these 6 trigonometric, we're just finding the 3 trigonometric functions, sine, cosine, tangent. So sine of pi over 2 is going to be equal to what we have, y over r, right? But y is equal to r, so we could substitute that in and get r divided by r, which of course would just give me 1, right? So sine of pi over 2, sine of 90 degrees or pi over 2, is equal to 1. Cosine of pi over 2 is equal to, so this would be x over r. My x value is 0, and that would be divided by r, which I know r is non-zero, so this expression would be equal to 0 then, right? So cosine of pi over 2 is 0. And then sine, we did sine, sorry. Tangent of pi over 2 is equal to y over x. So that would be, y over 0, or in other words, r over 0. So we're dividing by 0, which we can't do, so this would be undefined. Right? So this is undefined. All right. So then similarly, part B, here theta is 360 degrees, so let's start by drawing the situation. So my point P is going to be on the x-axis. Right, where this is theta, which is 360 degrees. So my xy coordinate for point P, x would be equal to r, right? So this distance is r, so my x value is equal to r, and my y value is going to be 0 since we're on the x-axis, right? So just making some notes, we would have that x equals r, where r is greater than 0, and y is equal to 0, right? So sine of 360 degrees is equal to y over r. So y is 0, so we'd have 0 over r, which would just be equal to 0, right? Cosine of 360 degrees would be equal to x over r, which is equal to, so substituting r in for x, we'd have r over r, which gives me 1. And then tangent of 360 degrees would be equal to y over x, which is equal to 0 over r, which is equal to 0, right? 0 divided by a non-zero number would be 0. Right? So it's just another example practicing those. Right. So now we're ready to move on to objective 2. which is determining reference angles, right? So if we let theta be an angle in standard position, the reference angle for theta is the acute angle. So we often denote that as theta prime, and it's formed by the terminal side of theta and the horizontal axis, right? So let me show you what this means for each quadrant. So in quadrant 1, right, theta in quadrant 1 is going to look something like this. So here's theta. So this would also be the same thing as theta prime, right? The reference angle would be the angle. So anytime you have an angle that's in quadrant 1, your reference angle is just going to be equal to theta, right? When you're in quadrant 2, right, we're going to have some angle over here, where that's theta. So then your reference angle is, you basically just draw a line to the x-axis, right? So it would be this angle, which would be theta prime, right? So thinking about how to find theta prime, theta prime would be equal to, so if we're in degrees, over here this is 180 degrees. So to be able to find theta prime, what I could do is take 180 and subtract off theta, right? And that would give me the difference, which is theta prime. So theta prime would be equal to 180 degrees minus theta. Or if you put this in radians, we would have theta prime equals pi minus theta, right? Because remember, 180 degrees is also the same thing as pi, right, in radians. So we're taking the total minus the part to get the other part, right, essentially. So then if we're in quadrant 3, let me just draw this. So we'd have some angle over here. So here's theta. So then, see, this part here would be theta prime, right? So then, in this case, to get this missing part, we'd want to take theta minus 180, right, to figure this out. So in other words, theta prime would be equal to theta minus 180 degrees, or theta prime would equal theta minus pi, right, if you're in radians. And then lastly, if we're in quadrant 4, right here, in this case, we're going to have some angle over here, where this is, where this part is theta. So then the reference angle would be this angle here, right? So to calculate theta prime in the fourth quadrant, you're going to take 360 degrees minus theta, right? Or if you're in radians, that would be 2 pi minus theta, right? So then I have an example here with 4 parts, practicing finding the reference angle theta. So if it's helpful to you, you could start off by drawing the picture. So when you have a theta of 150 degrees, you're going to have some angle over here, right? So what we're trying to find is this angle, right? So it's always the angle that goes to the x-axis, right? Just draw it, down or up, right? So this is theta prime. So we're trying to figure that out. So I could find theta prime by taking 180 degrees minus theta, which would be 150 degrees. So that would give me 30 degrees, right? So this missing angle here, this part, would be 30, because we know, all the way is 180. So then if this part's 150, then this part must be 30. Right? All right, so then the next one, we have theta equals negative 7 pi divided by 8. negative 7/8 pi. So notice that that is not in between 0 and 2 pi like we typically like it. So what we could do is find a coterminal angle that we've talked about before in prior section, and we could figure out what that would be, right? So maybe the first thing we look for is the coterminal angle. So if I take negative 7 pi eighths, remember I can add multiples of 2 pi. So if I add 2 pi to this, that would give me negative 7 pi over 8 plus, so I'm going to get a common denominator, so that would be 16 pi over 8. That's what we could rewrite 2 pi to be. So then adding that together, we get 9 pi over 8, right? So then that's going to be bigger than, so just this is coterminal to theta, right? So if we draw this, 9/8 pi is going to be a little bigger than 1 pi, right? So here's pi, so we're going to be a little bit bigger. So this guy is 9 pi over 8, where this part is actually theta, which is negative 7 pi over 8. What we're after, I'll draw this in red, is this angle here, which is theta prime, the reference angle. So probably the easiest way to find theta prime would be to take 9 pi over 8 and subtract off pi, right? Subtract off this part here to find the remaining part. So this would equal 9 pi over 8 minus 8 pi over pi, which is equal to pi over 8, right? So that is my reference angle, right? That's that little part here. So we're pi over 8 over pi. So the next one is sigma equals 5, right? So remember, since radians or degrees are not labeled, there's no label, it's assumed that that's in radians, right? So this is in radians. So a full rotation is 2 pi, which is over 6 radians. So here we're within 1 full revolution, right? So remember here is 0/2 pi. Here is going to be pi over 2. This is going to be pi. This is 3 pi over 2, right? So 1.5 pi, would be something like 4 point something, right? So I know 5 is going to be somewhere over here in this quadrant, right? So from here to here, that's theta, which equals 5. What we're trying to find is this guy, the reference angle, right? Remember, reference angle is always the acute angle. So to figure out that part, we would need to take so theta prime would be equal to 2 pi 1 for rotation minus 5, right? Which we could just leave like that, right? There's really no way to make that any simpler, right? So then the last part here, we have theta equals 13 pi over 3. So again, that's bigger than 2 pi, so we might start by getting a coterminal angle to that, rather than having all of those rotations, right? So excuse me. So then 13 pi over 3, right, we can subtract off 2 pi, which would be 13 pi over 3 minus, we need a common denominator, so multiply top and bottom by 3, so that would be, 6 pi over 3. That would get me to, 7 pi over 3. So that's still bigger than 2 pi, right? So we could subtract off 2 pi again, so we'd have 7 pi over 3 minus 2 pi, which would be 7 pi over 3 minus 6 pi over 3, which gets me to pi over 3, right? So basically, since we subtracted 2 pi twice, right here, what we have is, essentially like here, this is the angle pi over 3, but what we did is we had 2 rotations to have theta equals 13 pi over 3. So we just remove those unnecessary rotations, right? Because we still are going to land at the same spot. So instead of having 13 pi over 3, we're rewriting this just as the angle pi over 3, right? Which gets me to the same spot, right? So since this is in the first quadrant, that's going to be the reference angle. The reference angle will just be pi over 3, right? Because it's already acute. All right, so now we're working on objective 3, which is being able to evaluate trigonometric functions using reference angles, right? So here we're kind of putting together the sine idea, the reference angle idea like I promised, and thinking through how these trig functions will work, right? So let me draw a diagram. So let's say we just have like this general setup like we've been having with point P, which has a coordinate x comma y. Let this be theta, where this portion would be my reference angle. We're making a let me make this a little bigger actually. Oops. Right, so then let me erase this part. Oops. So then this, if we just draw like a triangle straight down, right, this distance here would be the square root of x, and this distance here would be the square root of y, right, because distance is always positive, right? So in this case, my x coordinate is going to be negative, my y coordinate is positive since we're in the second quadrant. But if we think about this, where this picture could be in any quadrant, then if we apply the absolute value of the x and y coordinate, that will always be true, right? And then, so this was theta prime. And then, this distance between the origin and P, point P, that's still going to be r, right? So remember, my trig functions depend on x, y, and r. So the idea with this is if we find a reference angle and find the trig function of the reference angle, that's going to be have the same value if we ignore the sine as the trig function evaluated at theta, right? So let me kind of put this in words, right? So essentially what we're recognizing is that in general, sine of theta is going to be equal to sine of the reference angle, theta prime, except possibly the sine, right? So if I take the absolute value of sine theta, that's going to be equal to the absolute value of sine theta prime, right? So we're essentially getting rid of the sine issue, right, by doing that. So if we think about like cosine of theta, that's going to be equal to x divided by r, right? In this case, we don't have to worry about the absolute value of x because I'm evaluating at theta. But cosine of theta prime is going to be equal to, you know, the adjacent side over the hypotenuse, right, of this right triangle I drew. But this would be equal to the absolute value of x divided by r. Right? So notice cosine of theta prime is always going to be positive, where cosine of theta could possibly be positive or negative, right? Or maybe even 0, depending on where theta is. So just a note here is what we could say is that cosine of theta and cosine of theta prime are equal except possibly for their sines. Right? So then to be able to evaluate trig functions, the steps are essentially going to be to find the trig value of the reference angle and then change the sign if needed. Right? So let me just write this off to the side here. Right? So these are the steps to evaluate trig functions using the reference angle. That's theta prime. Right? So step 1 is to find the trig value of theta prime, the reference angle. And then step 2 is to change sign if needed. Right? And what we're going to use to do that, remember, is all students take calculus. Right? So we're kind of putting all of that together. Or we are putting all of that together that we've learned in this section. So let's practice this. So example 4, we have alright, so that's basically the end of like the material. So we have just examples left to do looking at this. So example 4, we have 3 parts to evaluate the functions. We're trying to find cosine of 5 pi over 6. Right, so again, I highly recommend starting with a picture. So 5 pi over 6 is going to be, you know, just less than pi. So here it's going to be theta equals 5 pi over 6. And this part here is going to be theta prime, which, you know, that's not too terribly difficult to do. That's just going to be pi over 6. Right? And you can, you know, work that through if you'd like. So theta prime is going to be equal to pi minus 5 pi over 6, which is going to be 6 pi over 6 to get a common denominator, minus 5 pi over 6, which gets me to pi over 6. Right? So we're just pi over 6 short from being at pi. Right? So then the idea is if we make a right triangle, so basically have this right triangle and pull that triangle over here, right, maybe just for a little ease, this is pi over 6, which is theta prime. And then that would leave this to be pi over 3. Oops. So this is my 30, 60, 90 triangle, right? It's just in radians. So pi over 3 is bigger than pi over 6. Right? So remember that the hypotenuse is 2, and that what we have is square root of 3 and 1 left to label. So radical 3 is going to go across from pi over 3 because it's a bigger angle, and 1 will go across pi over 6. Right? So this pi over 6 is the angle that I'm thinking of. So we're trying to find cosine. So cosine of pi over 6, right, is going to be equal to, so we would have the adjacent over the hypotenuse, which would be equal to radical 3 over 2. And then next we need to think about, all students take calculus. So our actual theta, what we're trying to find, is in the second quadrant, right? It's here. In the second quadrant, cosine is negative, right? Because the only thing that's positive is sine. So in other words, cosine of 5 pi over 6 is going to be equal to negative radical 3 over 2. Right? So just following those steps. Right? So find the trig function of the reference angle, and then change the sign as needed. So cotangent of negative 120 degrees, right? So if we draw this setup, negative 120 is going to be here. We're going this way. So this part would be my reference angle, right? So thinking about this, 180 makes a straight line. We went 120 degrees. So this would, what's left, this would be 60 degrees, right? So theta prime, the reference angle, is 60 degrees. So cotangent of 60 degrees is equal to, so this would be, so remember SOHCAHTOA. So tangent is opposite over adjacent. Cotangent is the reciprocal of that, so it would be adjacent over opposite, right? So let me just draw in my triangle here, right? So what I'm thinking is, drawing like a triangle like this. And I'm just pulling it over here so it's not so busy. So this is 60 degrees here. That leaves this with 30 degrees. This is 2. Across from 60 is going to be radical 3. Across from 30 is 1. So we're focusing in on the 60 degrees here. So the adjacent side of the 60 is 1. The opposite side is radical 3. So I multiply top and bottom by radical 3 to rationalize the denominator, so we get radical 3 over 3. And then don't forget, all students take calculus. So we are here in the third quadrant. So tangent's positive, which means cotangent's also positive in the third quadrant. So cotangent of negative 120 degrees is going to be equal to radical 3 over 3. Right. So then next we have cosecant of 7 pi over 4. So if we draw this x, y, so 7 pi over 4 is going to be in the fourth quadrant, right? It's just shy of 2 pi. So here's theta equals 7 pi over 4. So this part is theta prime. So theta prime is going to be equal to 2 pi minus 7 pi over 4. Oops. Which would be equal to, so 8 pi over 4 minus 7 pi over 4, which is pi over 4. Right, so this reference angle is pi over 4. So my triangle, right, so again, here's my triangle. I'm just pulling it over here. For this part, it's still sigma prime. So this would be pi over 4. That leaves this with pi over 4, and there's my right angle. So this is 2, radical 2, and radical 2. Right, so we're focusing in on this degree. So we want to find cosecant of pi over 4. Remember SOHCAHTOA. Cosecant of theta is 1 over sine theta. So sine is opposite over hypotenuse, so this would be hypotenuse over opposite. The hypotenuse is 2. The opposite is radical 2. Multiply top and bottom by radical 2 to get 2 radical 2 over 2, which is just radical 2. Right? And then now we need to apply the all students take calculus. So we are in the fourth quadrant. Cosine is the one that's positive, so that means cosecant, which follows sine, the sine of sine, which would be negative. So, in other words, cosecant of, we were at 7 pi over 4, is going to be equal to negative radical 2. Right. All right, so now we're on example 5. So example 5, we have two parts. The first part is evaluating the function cosecant of 11 pi, right? So the very first thing that I would want to do is find a coterminal angle, right? So we could take 11 pi minus 5 times 2 pi, right, which is 11 pi minus 10 pi, which is just pi, right? So we can subtract off or add, multiples of 2 pi, right? So we get an angle in between 0 and 2 pi. So pi is coterminal to 11 pi, right? So essentially what we've done is removed all these extra rotations, right? So we'd go around 1, 2, 3, 4, and then we'd land here, right? So we're taking away 1, 2, 3, 4. Actually, we'd go around one more time, right? 5 rotations away from this, right? So then what we land at is just a picture, a simpler picture that looks like this, right? So this is a so it's not equal to theta, but we could, I don't know, maybe call this theta sub 1, right? Because it's coterminal, which is pi, or 180 degrees. So then trying to find the trig function here, if we draw this, right, where this is point P, x comma y, then this distance here between P and the origin, remember, is r, and x in this case then is just going to be equal to negative r, right? Because remember, r is always positive, so since x value would be negative, we'd have to put a negative sign in front, so that would be negative r, and the y coordinate would be 0 since it's on the x-axis, right? So in other words, x is negative r, where r is positive, and y is 0, right? Cosecant of pi is equal to r divided by y, which plugging in 0 in for y, we would have r over 0, which is undefined, right? Because we can't divide by 0. So we don't have to worry about the sign here. It's just going to be undefined, right? So finally, we would just have cosecant of 11 pi is undefined. Right, so then in part B, we have cosine of negative 600 degrees. So similar, kind of a similar setup. Let's first find a coterminal angle. So we could add, 360 degrees to remove those extra rotations. And what you'll find is that 120 degrees is coterminal to negative 600 degrees, right? So you can do that on your own if you wish. So essentially what we have is a picture that looks like this, where we're here at 120 degrees, right? That's my coterminal angle. So my reference angle would be this piece here, which would be 60 degrees, right? Because it's going to add up to be 180, right? So then, so this is sigma prime, or theta prime. Right? So then, so another way to kind of look at this is that we have all students take calculus. So we are in the second quadrant here. So cosine is negative, right? So how I could write this, just another way to write this, is we could say cosine of negative 600 degrees is going to be equal to negative cosine of 60 degrees, right? So, if we try to find cosine of 60 degrees, let's see. All right, so just filling in our special right triangle. Cosine of 60 would be adjacent over hypotenuse, which is 1/2. So this would be equal to negative times 1/2, which is negative 1/2, right? So finally, we have that cosine of negative 600 degrees is equal to negative 1/2. Right, so that's maybe trying to do it more in one step. That's perfectly fine too, right? Just depending on what your comfort level is. All right, so the next two examples are maybe a little more involved. So what we're given is cosine is equal to negative 3/8, and we're told that sine is negative, so we're asked to find sine of theta and also find tangent of theta, right? So the first place that I'd want to start is thinking about the all students take calculus and thinking through. So we know that cosine is negative. We know that sine is negative, right? What quadrant is cosine and sine both negative in, right? Well, they're both positive in the first. Sine's positive here, so that doesn't work. So it's got to be here in the third quadrant, right? So knowing the sign of two trig functions, we can figure out what quadrant we're in, right? So so then also the next thing I would be thinking about is that cosine of theta equals negative 3/8, right? Well, this is equal to x divided by r. So remember, r is always positive, so this would be 8 here, so x would be negative 3, right? And actually, there could be a multiple of this. This is like the most reduced down triangle, right? So for example, cosine of theta could have been like, negative 6 over 16, but we reduced down the fraction. So these aren't necessarily the exact values of x and r and y, but what we're finding are values that would work, so we can figure out the other trig functions, which works just fine, right? So from this, we could say that one possibility is that x is equal to negative 3, while r is 8, right? So then to be able to figure out what y is, we could use Pythagorean Theorem, essentially, right? So maybe let's start by drawing a picture of what we have so far. Right, so we have something like this. We know the r value is 8, the x value is negative 3, and here, is going to be y. Right? Well, really, we could think of this as the absolute value of y. Right? So then, to figure this out, we could have 3 squared, well, negative 3 squared plus absolute value of y, quantity squared, equals 8 squared, and then solve for the absolute value of y. So this would be 9 plus absolute value of y, quantity squared, equals 64. So then subtract 9 from both sides, and we get the absolute value of y, quantity squared, is equal to radical 55. So then take the square root of both sides, and we end up with absolute value of y equals radical 55, right? So that distance is radical 55, but the actual y value, since we're in the third quadrant, is negative. So y is going to be equal to negative radical 55, right? So these are those three values for x, r, and y to, to figure this out. So then we're asked to find what sine and tangent are. So sine of theta is equal to y over r, which would be negative radical 55 over r, which is 8, right? And then tangent of theta is equal to y over x, which, just plugging these values in, we'd have negative radical 55 over x is negative 3, which just gives me positive radical 55 over 3, right? So then though that's what we were after, right? So this problem is a little more in depth because we had to put some things together here to figure some things out, right? All right. So then example 7, the last example for these notes. If you look at my completed notes online, I actually did the problem 2 different ways. So for the time's sake of the video, I'm just going to do it the first way, and then you can look online for the alternative way if you'd like. Or actually, I think I'm going to do it the alternate way in the video, and then you could look at the other way using the Pythagorean identity, sine squared plus cosine squared equals 1. I think maybe using the alternate method is probably the easier method and more like example 6, right? So I'm just going to try to keep it consistent, right? So so the first thing is we know that theta is in quadrant 4. We're told that, right? So maybe start by drawing that picture. So here's theta. We know that sine of theta, which is equivalent to y over r, is equal to negative 5/13. Right, so that would leave me with y being equal to negative 5 and r equal 13. Right? So we want to find x, right? So, we would have, negative 5 quantity squared plus the absolute value of x quantity squared equals 13 squared, right? So x squared plus y squared equals r squared, essentially. By just using Pythagorean Theorem. So this would be 25 plus absolute value of x quantity squared equals 13 squared, 169. Subtract 25 from both sides, we get absolute value of x quantity squared equals, that's what, 144. So then we take the square root of both sides, and what we get is the absolute value of x is equal to 12, right? And x would be positive here because we would go towards the right, right? So that leaves me with x equal to just 12, right? So this is another Pythagorean triple, right? 5, 12, and 13 is a Pythagorean triple, like we talked about before. So we're asked to find cosine and tangent, so we can just figure these out pretty quick, right? Cosine of theta is equal to x over r, which would be 12 over 13, right? And tangent of theta is equal to y over x, which is y is negative 5 and x is 12, so we get negative 5/12, right? So that concludes this section. So let me know if you have questions. I'll be glad to help. Thanks.